This quiz problem presents a scenario where we're using scikit-learn's compute_class_weight function to handle class imbalance in a binary classification problem. We have 100 training samples, 90 belonging to class 0 and 10 to class 1. The goal is to determine which statements are true about the class weights computed using the balanced mode. It's all about understanding how the function handles imbalanced datasets and how that translates into numerical weights. This option suggests that the weight for class 0 will be approximately 1. We'll need to calculate the actual weights to see if this holds true. This option proposes that the weight for class 1 will be roughly 9. Again, this is something we'll verify through our calculation, keeping in mind that the balanced mode emphasizes the minority class. This option claims the sum of the class weights equals 2. This is a common misconception. The sum isn't always fixed at 2 or 1. The balanced mode focuses on the ratio of weights, not the absolute sum. Let's see what our calculations show. This option highlights the core principle of the balanced mode. Class weights are inversely proportional to their frequencies. The minority class gets a higher weight to balance the class distribution. Let's see if our computations support this. The approach involves using the formula employed by compute_class_weight in the balanced mode. We don't necessarily need to run the code. A manual calculation based on the formula is sufficient to solve the quiz and grasp the concept. This outlines the steps. First, we determine the proportion of each class within the data. Then, we apply the formula specific to the balanced mode to compute the weights. These weights will reflect the inverse relationship between class frequencies and their assigned weights. It's a systematic way to approach the problem. This line introduces the multiple-choice quiz question related to the class weights calculated earlier. It sets the stage for evaluating the understanding of the concepts demonstrated in the problem. This line presents the core quiz question. It directly asks participants to assess and select the true statements among the options provided, A, B, C, and D, based on the calculated class weights. It is crucial to note that each option evaluates a different aspect of the class weights, which can vary depending on the interpretation of the data. This is a multiple-choice question asking you to assess your understanding of how class weights are calculated using scikit-learn's balanced mode. It tests your ability to interpret the results obtained after calculating the weights for each class in the dataset. This statement checks if you understand the weight calculated for the majority class, class 0. The question presents a calculated weight, and this option asks if it's close to 1. This probes your understanding of the weight assigned to the minority class, class 1. You are asked whether the calculated weight is near 9. This allows us to check if you understand that the minority class gets a much larger weight due to the balanced mode in compute_class_weight. This option is a common misconception about class weights. The question aims to test if you know that the sum of the weights isn't necessarily 2. The balanced mode focuses on making the weights inversely proportional to the class frequencies. This statement gets to the heart of the balanced mode in compute_class_weight. It checks if you understand the core principle. The minority class receives a higher weight than the majority class to compensate for the class imbalance. The ratio of weights reflects the inverse ratio of the class frequencies. This introduces the core concept, using a tool in scikit-learn to tackle class imbalance. We'll specifically look at how weights are calculated in the balanced mode. This specifies the size of the dataset. The total number of samples will be used in the weight calculation. This describes the number of samples belonging to class 0. This number will be crucial for calculating the weight of class 0. This is the number of samples belonging to class 1, the minority class. This, along with the total samples, will be used in class 1 weight calculation. This sets the mode for computing class weights. The balanced mode ensures that weights are inversely proportional to class frequencies. This is a key concept. This is the formula used to compute class weights in the balanced mode. Here, n_samples is the total number of samples. n_classes is the number of classes. 2 in this case. n_samples_in_class is the number of samples in the given class. Let's break it down step by step. This shows the calculated weight for class 0 using the formula. It demonstrates the application of the formula to the majority class. This is the calculated weight for class 1, the minority class, using the same formula. Note that the minority class receives a much higher weight. This sets the stage for a multiple-choice question based on the calculated weights. This is an option in the multiple-choice question. It presents a possible answer for the weight of the majority class. This is another option, providing a proposed weight for the minority class. This option poses a condition on the sum of weights for both classes. This option states the relationship between the class weights and the frequency of each class, which is the core principle of the balanced mode. This is a key concept to keep in mind. Hope this helps. Hey Vamsi, this line introduces the core concept. We're using scikit-learn's compute_class_weight function, a tool to adjust for class imbalances in our data. Think of it as giving extra weight or importance to the underrepresented class to balance the decision-making during machine learning. We'll be using the balanced mode, a specific way to calculate these weights. Here's the dataset we are working with. A total of 100 data points. This is our training set, the data that we use to train our machine learning model. Out of those 100 data points, 90 belong to class 0. This is our majority class. It's significantly larger than the other class. And the remaining 10 data points belong to class 1. This is our minority class. It's much smaller than class 0. This imbalance is what we need to address using our class weights. Now, let's tackle the imbalance. We'll calculate weights for each class using the balanced mode. This method ensures that the weights are inversely proportional to the class frequencies, meaning the minority class will get a higher weight.